Hi, my name is Ben Jacobin, and I'm the Android teacher here at Treehouse. Thanks for joining us today. Before we get started, I just want to say, if you have any questions during the presentation, please type them below the video, and we'll try and get to them at the end, or if it's especially important, then my friend Chris will flag me down, and we'll try and answer it while we're doing the presentation. If we don't get to your question, or if you're watching this later and you think of something, then post it in our Treehouse forum, and somebody will try and answer it for you, myself included. Or you can find me on Twitter at Ben Jacobin. All right, so we're going to cover the basics of SQLite for Android. And the first question we want to ask ourselves is, what exactly is SQLite? It is a lightweight SQL-based database for storing data in an app. It's available in all versions of Android. And a good example to think of is the Contacts app, where you have information about all the different contacts. If you think of the database that sits behind it, you've got people's names and phone numbers, pictures maybe, and that's all stored in a way that you can access it from that app at any time. If it were just, well, let me go ahead to the next slide and explain. Why exactly do we want to use this? It's so that we can store and retrieve data within the app across sessions. That's the big thing. This is about data persistence. When we have data in an app, if we're running it in an activity, and if the app is visible on the screen, then that data in memory is available. But as soon as we close the app, that data in memory goes away. So we need to store that data in memory on the phone or on the tablet somehow. So that's why solutions like SQLite databases are used to persist that data across sessions. The reason we're looking at SQLite specifically is very popular with Android developers. A lot of software developers are familiar with SQL databases and using the SQL language to access and store data. You might be wondering if it's secure. Well, it is, in that the databases exist only within the context of the app. Android has a concept of sandboxing apps, where apps and all of their related files, databases, etc., are all in a restricted section of the file system, and no other apps or anything else can access that part of the file system without explicit permission. So if you want to give access to this data to outside apps, you have to explicitly allow it using a content provider, which we're going to talk about briefly in a moment. The other thing is, when you uninstall an app, it does usually delete the data. As far as I know, from, I forget which version of Android, there may have been some inconsistencies earlier on, but when you delete an app, the corresponding database and all the files in that sandbox should be deleted. We're going to keep things pretty basic today. We are going to talk about the CRUD operations. So if you are familiar with web development or other, working with data, then these are the basic operations you can perform on data. The acronym CRUD stands for Create, Retrieve, Update, and Delete. Now, in the syntax of SQL, that is instead insert, select, update, and delete. And I should mention about SQL specifically, SQL stands for SQL, stands for a structured query language. Now, if you're not familiar with SQL, then we have a fantastic course by Andrew Chalkley called Database Basics, and it will get you comfortable with creating databases, manipulating the data, and it's all based on the SQL language. We're going to work with very basic data. We're going to get some forecast data from the web, and we're going to store it in a table, and all we care about right now, just to show how to use these concepts in Android, we're going to do one column of data, which is numbers that correspond to temperatures. We are also going to talk about upgrading databases. So that is when let's say in our app we are tracking information about a user, and we have a username and an email address and a picture. Well, we release a new version of our app, and now we want to track additional data too. Let's say we want to store their favorite video game for some reason. Well, we need to amend the data that's currently in our system, and there's different ways we can do that. We can, because we have an existing database for the people who have the previous version of the app, we can either drop the database and recreate it, migrate the data over somehow, or we can alter tables in place and add new columns like this, where the existing data stays the same, and then we populate the new columns. So we'll take a look at that later on after we cover those CRUD operations. Now, the last thing I mentioned before we get started with actual code is the idea of content providers. A lot of times you'll hear content providers talked about in the same conversation as SQLite databases. And a content provider is an Android construct used to manage structured sets of data, and a database is a structured set of data. They're primarily intended to be used by other applications, which is why I said you have to explicitly provide access to your data to other applications through a content provider. But you don't need a provider to use an SQL database if the use is entirely within the context of your own app. So that's what we're going to do today. We're just building a very simple app that's going to have its own data. We're not going to provide it to anywhere else. That's a topic for another workshop or another Treehouse course. But I do want to just mention before we get started one more thing about the content providers. There was a good discussion that one of our mobile developers, Joe Steele, mentioned to me about the benefits of using a content provider. It is a best practice, and this is a Google Plus conversation that was happening with some Android developers about the pros and cons of using a content provider. I'm going to provide all these links for the workshop when this is published in a few days. So anything that we cover on the web, come back when this is published in a few days and you'll be able to find these links, or you can search for this here. Okay, so what exactly are we building? We are going to build a simple weather forecast app using an API provided by Forecast.io. Now, if you're not familiar with Forecast.io, it's a web-based weather app that is available also as a web-based app on your phones. So it's a really great example of the kind of web app you can build on a phone using web technologies. It's not a native app. It's completely built from the website. But they do some really neat things with animations and making it feel like a native app despite it all being web technology. And the reason we're using this site is they have a friendly developer portal where you can access their API to get some forecast data. It's free. You can sign up. If you just come here to developer.forecast.io and register, you create an account, and you get an API key that unlocks your access to their API. That way they can shut you off if you're abusing it. But it's a pretty, I don't remember the exact numbers, but you get a lot of calls, so it's really useful to build some simple weather apps. And they give you a lot of information. So I've switched here to the output from the API, the forecast call. So this is a JSON output, and I'm formatting my JSON with a Chrome extension called JSON View. You can see the plain source looks like this. But if we close this and go back, we get information about our current location, and then we get different types of forecast, the current conditions, minutes, hourly, daily forecast. We're going to look with the hourly forecast because it gives us a set of 48 data points to work with. And because we want to show inserting multiple data points and manipulating it, this is just a simple data set of 48 data points. We know what we're getting, and we can work with it from there. Okay, so let's get started with our code. I'm building this app in Android Studio, and our Treehouse projects currently use Eclipse, but everything we do here in Android Studio, the code, you can just transfer to Eclipse. The only thing that's different is the project setup itself. So when you create a new project, you'd have to manually add these code files in Eclipse. There's no easy way to migrate from Android Studio to Eclipse. The reason I'm using Android Studio is because the tool itself just gets better and better, and I want to encourage you, if you're comfortable, to try out Android Studio. Take a look. I had a different workshop a couple months ago about getting started with Android Studio, so if you want to check that out, it's available now as an Android Tools course, so you can review getting started with Android Studio and then take a look at this project. All the code that we write is also going to be available for download, so you'll be able to take a look. And the idea is we're going to walk through it, write some code, explain what's going on, and then you'll have a nice, simple example to get started with your own code. You can take these examples and either copy it and manipulate it, or maybe even use some of it directly in your own applications. And it's the kind of thing where it's good to know how you do it, but then once you get an example, you can just reuse your existing code. So let's, before we do anything, this code is incomplete, but let's run it just to get a quick look at the app itself. Okay, and it's about to load here on my Genymotion emulator. And this is another topic that I covered in that Android Tools course. Genymotion is a third-party emulator that usually works better than the default emulator. It's very fast. They have all sorts of different devices you can try. So in general, I highly recommend using that for your development purposes as well. It's the next best thing to having an actual device to develop on. So you can see here, this app just has two activities. The first is this front one that has our CRUD or ISUD operations, insert, select, update, and delete. And we're going to start with just creating a database and inserting some data. Makes sense. It's a good place to start. So back in our project, here's the two activities we're working with. And the services package here, I've got my code organized into a couple sub-packages. So the UI package is for our activities. Services is for the code related to getting data from the web. So I'm not going to review any of this. It's here. You can get the data from the web however you want, whatever data you're going after. But I'm using a library called Retrofit. It's an open source library from Square. And I haven't used it much, but what I have used I really like. And so I recommend checking that out as well. Could be a topic for another live stream. But the code here, just as a quick review, you give it the base URL, and then you configure your weather service or whatever service you're writing for. And the library makes use of these annotations, and it generates a lot of code for you behind the scenes. It does a lot of magic, but it does it in a way that makes it very clean and easy to understand. So here, the method to load the forecast data, we create a new REST adapter because our web service we're going after is a REST API. And we call this get forecast, and it runs asynchronously. So it goes out, requests the data, it uses the key and our current location, and then when it's all done, when the asynchronous call finishes, it calls back with this callback method. Now this is that common asynchronous processing with a callback that we've seen in a few of our Android projects. So when it calls back, we'll go back. So we're calling this from our main activity. And when the data returns, we pass in this callback down here, and it's a retrofit callback, and it has two different methods that we need to override. First is success, which will include a forecast object, and that's the other object we have over here. This is a mapping of the data from the JSON file. This is a very simplified version. To map the entire data set would be a bit more of a complex class structure, but this drills down. The reason I have it minimal like this is so that we can get after that hourly data, the temperatures specifically that we want. So on a successful call, let's go back to main activity. We get that forecast object, and right now we're just looping through. So if we run this, we're going to run it just to make sure in the log, I'm outputting the current temperatures just to make sure that we're getting data. Let's proceed with actually creating the database. So I've got this other sub-package here called DB, and that's where we're going to put our database classes. So before we write anything, let's take a look at the Android documentation. Now, I'm a little bit, in general, I really like the Android documentation. I think they do a great job of explaining how to do things, providing example code. I use it all the time. I use it in our courses. But the documentation about SQLite databases is a little bit obtuse, and well, it is what it is. So hopefully this course is enough to get you started, and then you can work your way through the navigation, through the documentation as needed. But if you search for saving data, you can find this reference of how to save data in SQL databases. And we're going to walk through these steps, but the first thing we need to do is create a database using a SQL helper. And we do that by extending a base class called SQLite Open Helper. So we're going to create our own custom class that will extend that base class and take care of the create operations for us. So if I right-click on DB and select New Java Class, we're going to call this our forecast helper. Okay, and we are going to extend the SQLite Open Helper. Okay, and right away we get an error that we're missing some required methods. SQLite Open Helper is an abstract class, which means we can't use it directly. That's why we need to subclass it like this. And we can use Alt-Enter to bring up a quick fix for implementing the methods. And if I hit enter here, we can create the two methods that we need. This will be just the stubs, and click OK. And there you go. You see the first one is called onCreate, which is used to obviously create the database. The second is called onUpgrade, which we'll look at a little bit later on, and that's when we want to upgrade the database from one version to another. Okay, so we still have a warning here about a missing constructor, so let's take care of that. Now, if we do a quick fix here, if I hit Alt-Enter and create the constructor, we get a little more information than we want. This is to create it, passing in a bunch of information, but we're going to just make this information part of the class. So our constructor will instead just require the context, which is a common pattern, and then we will add these individual parameters here in the class. So the first parameter here is the name of the database. We can name this whatever we like, and let's make it a constant here, and we're going to make it a public constant for the database name. Well, actually, no, let's make this one a private. Some of these constants we're going to make public because we'll reference them elsewhere, but let's make this a private static final string called db name, and we'll call this temperatures. And we have to give it the .db extension. Okay, so now we can use this db name here in the constructor, db name. Now the next parameter, we just are going to pass in null. This is, what's this parameter? It's a, I don't remember off the top of my head, but we don't need it for this. And the version number is just an integer version, and this is how we know if we're upgrading the database or not. So let's make this a private static final int, and we'll call it db version, and we'll set it equal to 1 because we're just starting out with 1. It's an integer value, so it's going to be 1 and above, and we need to increment the version when we're upgrading the database. So let's pass in db version here, and now our constructor is complete, and we can focus on the onCreate method. Let's go back to our documentation. Oh, right, okay, I apologize. So the next thing we want to do in here is use our database object to run some SQL to create a table. So the next thing we need is the table name that we want. And this is the constant that we're going to make public. So the first final string table, and we'll call this table temperatures, and we'll just set this equal to, we'll do these in all caps. That's a common SQL convention, is to write in all caps, temperatures. Okay, and let's define our database create statement. So what we're going to do is use the SQLite database that's passed in here as the parameter into the onCreate method. It's called db. So if we type db and look at the content assist here, then we see a command for executing SQL, and this is where we can write raw SQL. Now, in some cases with working with SQLite, we want to write, in some cases we will write raw SQL like this, where it's a create statement that's just a basic SQL statement, just like you would see working with any database. Other times we're going to use some methods and some classes to encapsulate that SQL and work with it in a different way, a more modular way that makes for cleaner code for us. It's a cleaner interface between our app and the underlying database. But here, we're going to pass in a string called dbCreate, and then let's go up here and create that with the variables we've defined. So another private static final string named dbCreate. And right now, we're going to plug in some variables, but let's write this as if we were writing it right in some kind of SQL editor. So we are going to write create table, and the name is temperatures. And when we create the table, we need to define the columns that are included and the data type of those columns. So the first column, and they go in parentheses here. The first column we're going to use is a primary key that's just an integer ID. And we don't need it for this example. Like we saw in the full screen earlier, we're just going to work with temperatures. It's just going to be one column of data. However, if we include this ID column that I'm about to write, it's a common convention for working with SQLite and Android, and we need that column to work with certain things in the future. So for content providers, for example, or content adapters, when you're adapting your data for views, they require that ID column to be in place. So it's a good practice to generally create it, even if you're not going to use it yourself. And we don't really need to worry about it. Once we create it, we're done with it because we're going to create it in such a way that it auto-increments in the database by itself every time we insert data. So the first column, the convention is underscore ID, and it is of a type integer. And then we're going to add that additional information to make it the primary key that auto-increments. Okay. The second column is our temperature column. And the data type for this is just real. So there's just a few basic data types available in SQLite. And the real data type is for numbers that have a decimal value. So if we take a look at the data that we're getting back from our API, we see that the temperature is given with a decimal value. So we're going to maintain that accuracy and store it with a decimal in our database. Okay, so now let's plug in the actual values, the variables, instead of having this all hard-coded. So here, instead of temperatures, let's plug in table temperatures. Okay, and then we're going to create column names as well for these variables. So instead of underscore ID, let's use a variable called column underscore ID. And we're going to add that in a second. And then also down here, let's do column underscore temperature. And leave that data type. Okay, so now we just need to define those two variables. I'm going to copy and paste here. First one, column ID. And this is where we had that underscore ID. Second one is column temperatures. And I'm sorry, just temperatures. This is an individual row, an individual value within our temperatures table. So we just use temperature. So now we have these variables defined, our create table statement is ready, and we can execute it here within the context of our onCreate method. So we're almost ready to create our database and make sure that everything is in place. But before we do that, we want to introduce another class. We're going to use two database classes to access our database. This database helper is what we use for defining the database and creating and upgrading it. But then we have a separate class we're going to create called forecast data source that's going to act as an interface on top of this forecast helper. And the forecast data source is going to do all of our operations. So our code in our app is going to use the call methods from forecast data source, and then there it will execute on the underlying SQL database. So let's right-click on the DB package, select New Java Class, and like I said, this one's called Forecast Data Source. And click OK. And this one doesn't have to extend anything. It's just that we are going to make use of that data helper class that we just defined. OK, so the first thing we need is a SQLite database object itself. So let's define a private SQLite database named mDatabase. And then we want our own version of that forecast helper. So we have private forecast helper, and we'll call this, let's call it mForecast helper. Okay, so let's start with the constructor. We're gonna write this code, and then we're gonna use it in our main activity. So the constructor is a public forecast data source, and we're gonna pass in the context. Again, we need to pass it along to the forecast helper class. And all we want to do here is, well, I should have created a context variable to hold on to. So we'll do private context, mContext. And now we can set mContext equal to the context. And the second thing we want to do is instantiate our forecast helper. So that's equal to a new forecast helper, and that requires the context. So we'll pass that in. Okay, and now this class is going to be responsible for a couple different things. So let's add some comments here, and we're going to define what we're going to do in this class, and then we're going to do it piece by piece. So the first thing we need to do is open a database, and then conversely, close one. And then we're going to do those CRUD operations: insert, select, update, and delete. Okay, and I know we're doing a lot here before running anything, and generally I like to do as little as possible and then test it to make sure that it's working. But we'll get this basic stuff set up, we'll run it, and then hopefully it'll make sense. We'll walk through exactly where each piece is, because it's we have these couple different pieces moving, but once we get into the main activity and call it, it should be more apparent as to what's going on behind the scenes for us. Okay, so let's start with the open method. So we'll call this open, and this one is special. We're going to throw a SQL exception just in case anything goes wrong. That's a generic SQL error that we want to watch out for with certain operations. But yeah, so this is just one line of code, and it's from our forecast helper. So we set our database, the SQLite database, from the forecast helper using a method called getWritable_database. And this is the important line of code. This is really what we were building toward. So a getWritable_database is from that SQLite OpenHelper method. SQLite OpenHelper class. And it's a method that will create the database if it doesn't exist, or just open the database if it exists for writing. Now in Content Assist, you may have seen there's a different version, getReadable_database. That's where if you want to have a read-only database. But we're going to be inserting data and updating, so we definitely want to be able to write. So now this is ready to use within our main activity. So let's switch over. And what I've done here is I've left a lot of code based on the UI and the buttons and things like that, things that you'll hopefully already know how to do based on our Android courses. But I've left notes for us to work through on the pieces we need to get the data in place. So the first one up here is to declare a data source, and that's going to be using our new forecast data source class. So let's make this a protected forecast data source, and we'll call it mDataSource. Okay, the next thing we want to do is instantiate that when the activity is created. So sure enough, down here, there's another note. mDataSource equals a new forecast data source. And remember, we need to pass in the context, so we'll use main activity.this. Okay, so this creates our data source object, and now that we have it, we can open the database. So if we just call mDataSource.open, then this should create the database and open a connection to it. So that's another thing we need to talk about is database connections. So the database, the way it works is once it's created, we open a connection to it, and that connection we use to write and retrieve data. And when we're all done with it, we have to close that connection. Now, it's important to manage opening and closing appropriately so that we don't leave a connection open when our activity is destroyed or our app closes, because you can end up with null pointer references or memory issues or corrupting the database somehow. So we have to carefully match opening calls with closing calls. So there are a couple different ways you can do this. One way would be to, whenever you want to perform a SQL operation, you open a connection, perform that operation, and then close it right away. That's fine, although if you're doing a lot of operations in an activity, you'll end up with a lot of open and closing calls, which there's nothing really wrong with it. The performance hit is minimal, but it just kind of clutters your code. So in general, what I like to do is open and close my connections in lifecycle methods of the activity. So just a quick review of the lifecycle of an activity. When it's first created, this onCreate method is called, and that's where we set up and instantiate a lot of variables, data we might need, tie things to the layout, etc. As soon as it's onCreate method is called, as soon as it finishes rather, the onResume method is called. So those two lifecycle methods are piggybacked on top of each other when an activity is first created. Then when that activity is sent to the background, whether the user navigates to another activity or a different app, closes the app, the onPause method is called. So you always think of onResume and onPause together. So if we open the database in onResume and close it in onPause, then we'll make sure that the database connection is only open while our activity is active on the phone. And that's the behavior we're after. So that's what we're going to do here. We're going to move this mDataSource open to the onResume method. So I've got it down here, again, a little note. Let's just paste it in. And here in onPause, we want our corresponding close method. So we call mDataSource.close. But wait, we haven't defined the close method yet. So let's switch back to forecast data source. And this is real simple. We said we are going to use a close method, public void close. And all we do is from this database method call the close method itself. So this is, again, just a wrapper. This is an instance where this forecast data source is really just a wrapper on the call so that we aren't interacting with the database directly in our code. All right, so at this point, there's no errors in the project, and it should be ready to run. So, and this is, I've got a brand new emulator instance here, and I ran it without any database code in here. So there's nothing currently on this Android phone, on this Android emulator. So if we run it, we should create a database. And we'll just wait a moment for it to load on the emulator. Okay, there we go. Oh, look, I got my logcat back. I forgot when I run the project. I'll bring it back. All right, so nothing to see here in the app yet because we haven't done anything. But behind the scenes, we should have created the database. So how can we tell? Well, if you remember, we created a database name called temperatures.db. And that's an actual database file that's available on our file system. So there's different ways you can look at files on the Android file system. If you're using Eclipse, there's a built-in file explorer from the DDMS perspective. But you can also use command line tools, and that's what we're going to use here because there's an additional command line tool that interacts with SQL directly. It's called SQLite 3. So let's take a look at how to use that tool and make sure that we do in fact have a database created behind the scenes here. So in the terminal, it depends on how you have your environment set up. You may need to navigate to the Android SDK. So if you look here, I've got I'm in the Android SDK that corresponds to Android Studio, and specifically I go into Platform Tools, and if I type ls for a list, then I see a couple different tools available, and what we're going to use is this one called ADB, which ADB stands for Android Debug Bridge. So the one thing I want to show is you can see the currently connected devices. If I do /ADB devices, then you can see the list of devices attached, and this is the serial number for my emulator instance, and we need that to connect to our SQLite. So let me go back to Chrome for just a moment. That's the next tab I wanted to show you. This is the tool from the command line that we're going to use to take a look at our database, and this is available under the Tools section. There are a lot of different command line tools available in Android, and we haven't really talked about many at Treehouse, but if you go in through a command line to a connected device like this, you can do some really powerful stuff to make sure that your development is proceeding as planned. So the next thing we're going to do is enter the remote ADB shell using this following command, and we need that serial number that I just showed you. So the next line, type ADB-S for serial number, and then I'll just copy and paste this, and we want the shell. Okay, so now this is a shell on the device itself, on the Genymotion emulator. So here we can use that SQLite 3 command. And if we just run this, sure enough, we get the 3 corresponds to the version of SQL. And here we got a SQLite prompt. And depending on your familiarity with SQL development, you may have used tools like this on other systems. But there's not much here. We need to instead open up to our own database specifically. If you type .help, you can see a bunch of different options. These are different commands you can run. You can type straight SQL in here as well and execute it as long as you end it with a semicolon. But if we look here at databases, we should get a list of databases. But it's not. This is not for our app specifically. We need to instead quit here. So we do .quit. And we want to open the connection to our database. And you can use the format here. So where is it? Here we go. This line here shows the path to an emulator device instance. It's data, package name, databases, and then you append the database at the end. So let's type that out, and that should make more sense. So SQLite 3, and then we pass in data, com.team, treehouse, and this is called, I called this friendly forecast, and /databases, let's see if that's correct, yep. And we called it temperatures.db. So that should open up. Okay, we got the command prompt. And now if we type, let's see, databases, I think it lists, yeah, there you can see the file that corresponds, the main database. Because we're in our temperatures.db, you can see the file name itself. Now if we look at the tables, we should have one table, temperatures. Well, there's a metadata, an Android metadata table that's included by default as well for your SQLite instance. But temperatures is the one we define, and you'll notice that matches exactly what we created in our forecast open helper class. So before we go on, let's make sure that this is what we expect. We can look at the schema by typing schema and then giving the table name, temperatures. And sure enough, there is the exact create statement we defined. It's got the ID column, and the second one is for temperature. Great. So that means our data is in place and we can start using it. So let's insert some data. So coming back to Android Studio, we're going to just work our way through this class. We've instantiated the database, we've created it, opened it, we're closing it on pause. So now let's take a look at the insert. So let's see where we're inserted. So if we go back to the app, we're going to have these couple of buttons here, and there's nothing to view, to select, update, or delete right now, so those buttons are grayed out. But let's add the code to insert. So there's an insert button, and when it's on the onClick listener, we're just calling this method called load forecast data. So if we scroll down a bit, we see that load forecast data calls our forecast service, and it calls that load forecast data, which executes a callback. So we're passing in, this is again what we went through when we took a brief look at this class. This is that load forecast data. So this callback gets executed when the data is returned, and that's down here. Right now we're just logging the data, but now we can go ahead and insert our new data. But we need a method to do that. so let's go back to our data source class because that's where we're writing our interface to all the database operations. And for the rest of these operations, we're going to make use of a SQL construct known as a cursor. So each of these methods is going to return a cursor, or in some cases, a different value. But what the cursor does is we say to the database, okay, go and get me this data. The database returns something called a result set, and it's a set of data in whatever format we need, whatever we requested, and then we use a cursor to iterate through that data however we want. So you can think of it as like a block of rows in a table, and we say with the cursor points to that block, and we can do operations like, okay, go to the first row, and it'll go there, and then from that cursor we can then access the values in that table. Then we can move the cursor around, we can just loop through, we can move to the end, different things. But right now with an insert, what we want to do is create the data and store it into the table, into that temperatures table. So the first thing, let's create the method itself. Let me just glance at my notes. Okay, public void insert forecast, and we have that forecast object which has all the data we want. Remember that forecast object is returning from the web service. So we'll pass it in right here, and we'll manipulate it from here directly. Okay, and it got a little bit ahead of myself talking about the cursors. That's actually more for selects and updates and deletes. But for this one, because we're inserting, we're just going to insert and assume success and come back. We're not going to look at the data that was inserted with a cursor, although you could certainly do that. So let's see, what should we do here? Let's insert, we're going to insert one row first, and then we'll talk about inserting multiple rows. So to do just one simple insert, now we're not going to write raw SQL. We're not going to create a SQL string that says insert into table of values, blah, blah, blah. We're going to use a method from that SQL open helper, or from the SQLite database class, rather. So the first thing we want to do is when we pass in values like this, whether we're inserting or updating, we use a class called content values. We'll name this values, and we'll just initialize it with a new content values. Okay, but now it's kind of like a dictionary or a hash map, things you might be familiar with. The content values, we put things into it. So for these values, we put a key and a value. So the key here, because we're inserting into our table, we're going to insert data into that temperature column. So we want the temperature key. And sure enough, that's why we made this public constant. If we type forecast helper dot column temperature, that gets us the appropriate column. And now we just need a value. Before we dive into the forecast object, let's just test it with a decimal value. We'll do a nice, beautiful 75-degree day. Okay. And now we can use these values in the insert itself. So from our database object that we have running here, we want to call insert, and the first parameter is the table. So forecast helper dot table temperatures. Second parameter is a null column hack. That's if you want to have null data in your table, you can allow null for certain columns. And this is, well, we're just going to use null now, but you can provide a value there if you need to get around some restrictions with your null columns. It does not matter for this purpose. And then here the last parameter you see are those content values. So what's happening is we're going to insert into our temperatures table the values that we just defined. So it's going to go to column temperature, it's going to add a new temperature of 75 degrees, and it's going to auto-increment that ID column that we defined, but you see here that we're not manipulating that ID ourselves. It auto-increments in the database behind the scenes. And that should be all we need for this insert. So let's go back to our main activity, and now we can replace this to-do with an actual insert. So once again, from the data source, we call insert forecast, and lo and behold, we have a nice forecast variable we can use that was returned. Okay, and these methods here, update high and low, we're actually not going to get to that because I don't think we'll have enough time. And then enable other buttons. So once we insert data, we can go ahead and start looking at select, update, and delete. So let's just save this and run it and make sure that we're actually inserting data. Okay, we'll give Genymotion just a second to reload. There we go. Okay, now if we click on insert, we should see the buttons enabled, assuming success. Great. And you see these aren't we're doing anything right now. That's okay. But how do we know that we actually inserted data? Well, we can go right back to the terminal, and it didn't have any data before, but now if we run straight SQL here, if we select everything, select star from temperatures, there we go. We have one row. The very first ID is 1 because it starts auto-incrementing from 1, and there's the 75 degrees we put in. Very good. Notice that the SQL is case sensitive, or it's case insensitive rather. So I typed in lowercase, although common convention is to type SQL commands in uppercase. That's why we have uppercase names in our classes. Okay, so let's take a look. We have 48 rows of data to insert, so let's put all 48 temperatures into our table. So we need to do that back in our forecast data source. And the forecast itself has an array of hourly forecasts, and we could just loop through each one and put them in. However, there is something we want to think about before that. Right now, if we just loop through and did it just like this using the database insert, then behind the scenes, there's a little bit of a performance hit. And every time we run a SQL command like this, the data is inserted and then immediately it's committed. So any kind of change is committed right afterwards. And when you're doing bulk SQL operations, whether it's in Android or any other system, what you want to do is try and delay those commits until you're either completely done or maybe it's staged commits along the process if you have a lot of data. So what we're going to do is we're going to group all of these 48 commits, all of these 48 insertions rather, into one single database transaction. So the transaction will start, we will insert 48 pieces of data, and then we'll finish the transaction and commit it. That just saves us a little bit of overhead. Because we're writing to the disk for the database, it's going to be completely negligible, the performance hit on this app, but when you're working with large amounts of data, you may see a little bit of performance degradation. And another thing we want to do when working with SQL databases with larger sets of data is make sure we do asynchronous operations. So just like when we're getting data or information from the web, and we may have some delay introduced there, we do things asynchronously with callbacks. Well, we'll do the same thing with database operations a lot of time. We'll execute asynchronously, and then when it's all done, we'll call back to our code and say, okay, data's ready, go on. So the first thing we need is to begin our transaction. So let's begin the transaction and then end the transaction, and then we'll go back and add our loop. So if we use our database object and call begin transaction, and then down at the end, we want to end our transaction. Okay, so now we can write our loop inside here. So let's do a for loop. We'll do a for each, and this is for each. I'm not going to go into too much detail about this. Is the model structure for our data. We'll call this our, and we're going to use the array from the forecast. It's called forecast.hourly.data. This corresponds, again, if you want to see, if you have questions about this parsing, certainly feel free to ask in the forum afterwards. But since that isn't the focus here, we're just focused on the SQL. But there's one more thing we need to do here. Because something might go wrong, we want to put a try-catch block here. We want to make sure we end our transaction no matter what. So instead of just, in case anything any exceptions were thrown, we want to make sure we have a finally block that guarantees that the transaction will be closed off. Because again, we don't want to leave the database in that in-between state where things didn't complete as anticipated. So this is that transaction itself, and then we want to trigger that commit that I mentioned, and we do that with mdatabase.setTransaction is successful, or set transaction is successful. So notice we're doing this here at the end. So after the entire for loop executes, we come down here and set the transaction is successful, and then we close that transaction. So let's, this should now insert, oh, but we haven't updated the temperature. So this is just going to insert 75 48 times. Instead, we have that hour variable. And from there, we can get the specific temperature, which is a double value. And that double decimal value corresponds to the real value in the database. So if we run this, we should be able to see in the app, we'll execute the insert. Okay. Oh, and I forgot to add some code that re-enables these buttons when we come in and there is data in the database. I had a check for existing data method, but that way these would be enabled because we do have data in the database now. And it was just a simple select count star from the database to make sure that there were rows in there. Okay, so I can re-trigger it with the insert. And if we go back to our command line, let's take a look at this. Unfortunately, I can't just type the up arrow like in a console, so I have to retype this SQL. But if we select star, there we go, 48 rows. Well, 50 is because we had existing rows in there already. Okay, so there's a different types of insert. We inserted one row and then we did a bulk insert. So this is fine that we can view things in the terminal, but it'd be nice to view that data in our app itself. So let's see how to select that data from the database and display it in the app. So to do that, we have a separate activity. That's the select button on the main activity. And if we go up here and look at the onClick, we see that we're just starting a new activity for view forecast activity. So view forecast activity is a simple list activity. And what it does is it's going to execute a query, select all the data from the database, and then display it in a simple list. There are different ways to do this. This is a very basic way. Again, if you're using a content provider, you can use a thing called a cursor adapter to adapt things. But it's, again, we're just introducing the basics here. This is just to show you how to get data in, get data out. So much like the main activity, let's do a few things about getting a data source. So we have a protected forecast data source named mDataSource. And we're going to instantiate it here in onCreate. So mDataSource equals a new forecast data source with the context of view forecast activity.this. Okay. Now we want to open and close it in onPause and onResume. So mDataSource.open and mDataSource.close, sure enough. And here we don't have any button or anything to trigger the action. We're just going to query all the data and bring it back to the display every time the activity is called with onResume. So let's add the code to select everything from the database, and then once we have that, we'll update the list. So let's go back. Again, you'll be familiar with this pattern now. We're going to go back to our data source object, and that's where we'll write our select method. So the first one, this is where I was talking about the cursor. So we're going to return a cursor to the result set. And let's call this select all temperatures. And we don't need to pass anything into this one, but we want to create a cursor variable. Call it cursor. And we're going to execute a query method from our database object. So this is, again, instead of writing the raw SQL, we're going to use the query method. We'll return the cursor when we're done. And I'm going to break the parameters for this method on multiple lines so that we can see exactly what we're doing. So the first thing we need is the data table that we're querying, because we're just working with one data table, but we can create multiple tables as well. So we could have temperatures, we could have a separate table for wind conditions or whatever we want, locations maybe. But this is the table name, which will go through our helper, and we'll use table temperatures. Okay. And then the second thing is the columns that we want to select. So the format here, instead of just a single column, we need to list these as an array of strings. So here, like if we put forecast helper dot column temperature, we would get an error, which, well, I'll just go ahead and fix it now. What we do is just pass in a new string array, and if we put curly braces around the string, that way we get the column names that we want. And this is just one column, but we could separate multiple columns as individual items in this array, which themselves will be separated by columns in here. Okay. So now there are a couple more parameters, but if we just are selecting everything from a table, then this is good enough. We just need to pass in null values for the rest of the parameters. So this first one is the where clause. Whoops, I forgot a comment. And what we'll do is we'll come back with a separate method and look at some of these in more detail. These are the where parameters. And then we can do more advanced SQL operations like group by. Again, we're just passing in null because we're not worried about any of these. Having, and finally, the order by clause. And if you want to learn more about any of these SQL constructs, again, there's the database basics course. Okay, so this should give us a cursor, and if we go back to view forecast activity, we can now create a cursor. Cursor, cursor equals, and then from our data source, we call select all temperatures. Now, what we're going to do is just pass this cursor into a method called update list, and we have it as a separate method because we're going to update the list in two different places. So if we go down to update list, you'll be familiar with the part down here. All it is a simple array adapter of decimals, and it's going to use a simple list item. It's just going to show a text view with the array with the values. And we're using a variable called mtemperatures, which is an array of big decimals. Now we're using big decimal here because double is not allowed. Primitive types are not allowed for inside generics like this. We need to use a wrapper class, which is why we have big decimal. It's just a conversion back and forth, but it gets us the same data that we want. So what we need to do here is loop through the cursor to populate our temperatures. So we start, the cursor is tied to our result set, but we need to, the first thing we need to do is move it to the beginning of the result set. So we say cursor.move to first. Then we're going to loop through the entire result set using a while loop. And here we're going to use a method, well, cursor dot is after last. So let's see, we'll do stuff in here, and then we're going to move the cursor with cursor dot move next. Okay, so we move it to the first one. We enter the while loop. It's not after the last because we're still at the first one. We're going to get the values we need, and then we'll move the cursor and then redo the loop until we're all done. Okay, so what do we want to do in here where we're doing stuff? Let's start with an index. So the way the cursor accesses, well, let's do this. The cursor, we get things based off the indices of the columns. So we're after a double value, and it's the temperature. And if we use the cursor, we can get all different data types. So these correspond to the different data types we can use in our SQLite database. We're getting a double based on the column index. So to get the column index, now we know that our column index is 0 because it's the only column in the database. Well, we have the ID column, but that one isn't indexed. So it starts at 0 for the columns that we define. So we could just pass in 0 here. But instead, let's get it. This is a little bit cleaner because we may change the order of our columns. So we want to avoid hard coding the numbers if possible. So instead, we have an index in I equals cursor. And lo and behold, there is a get column index based on a name. And the name is forecast helper helper.column temperature. That gets us the appropriate temperature. And now we can just add this temperature to our array of mtemperatures. So we're adding a big decimal. We need a new big decimal from the double value, temperature. Okay. And that gets us what we need. However, when you're converting a double to a big decimal, if you do it just like this with this simple constructor, you end up with a whole bunch of decimal places, so it's going to fill the entire list view, and it looks silly. We don't care about that precision because we're only getting data back in 2 decimal places. So a simple fix is to add a second parameter, a different constructor, and from a class called mathContext, we can use a decimal format, and this will just format our data in a little more of a presentable manner. And that should update our list. That's all we need here. We're looping through the cursor, setting the adapter, so let's run it and verify. Okay, we'll wait for Genymotion just a moment. Okay, and there's data already in the system, so we should be able to click on select, but again, I forgot to add that method to this prototype code. So we have to reinsert new data, and it's just going to keep appending data into our database, which is fine, because once we get to the end, we're going to delete it all. So now that we have the button enabled, if we click on select, then there is all the data that corresponds to what we saw in the SQLite tool in the command line. Okay, so that was getting everything, but also very common, we're going to select specific data, whether it's temperature for a specific hour or, again, like information about a specific user. So we want to use a where clause to limit the data we get back. So what I've done is added a field, an edit text up here in the action bar. And when we enter a temperature, it won't do anything right now, but when we enter a temperature, it's going to filter out anything below that temperature. So let's go back to our data source and add the method. And this is going to be, it's going to return a cursor because we're going to still have a result set. And let's call this select temps greater than, and then we'll pass in we're going to use a string value, min temp, just to make things easier. I'm not worried about type checking here, although in a production app we want to make sure that we're actually getting a number. This is just for speed's sake. Okay, so let's start with a cursor. Actually, what we're going to do is copy and paste, because all we're going to use the same format here, but we're going to add a where clause and where parameters. So let's copy everything here and paste it below. And the where clause is going to be a string. Let's call it where clause. And we'll define it up here. We could define it here in the method, but it starts to get a little too hard to understand. So let's add it up here. String where clause. And let's write the where clause we want, and then we're going to parameterize it appropriately. So here we're going to select all temperatures where temperature is greater than the minimum temp. So where temperature is greater than min temp. Easy enough. So let's swap out temperature from our forecast helper, our column temperature. And let's swap out min temp with a question mark. That is the placeholder value where we can add our parameters afterwards. So here we see the where parameters. We can put min temp here. Sure, we could append it in the string. This is just showing different ways to do it. But just like we had to use a string array for column names, we have to use a string array for the where parameters. So let's type new string, and we'll put min temp as the only item inside. And we won't do anything else with group by, having, or order by. But now we can use this method back in our view forecast activity. And that code for the action bar is down here in a method called configure action bar. And I'm not going to go into too much detail about this. If you have any questions, ask me in the forum afterwards. But you can see we have an edit text, and from that edit text we're going to use it as the parameter for a method called filter temperatures. And that's where we will do our magic work. We will call mDataSource.select temperatures greater than, and we'll just pass in that min temp. And when we're done, we're going to update the list with that cursor. Oh, I forgot to declare a cursor variable. Cursor equals the result from that. So this filter temperatures will be called when we hit enter. Set on editor action listener, when I hit enter, will use the value that was entered in that edit text. So let's run it to take a look. Okay, we'll give Genymotion a moment to reload. Okay, and again, we're going to have to insert more data. So we're just tripling or quadrupling our data now. Now if we hit on select, we get the list view of everything. And now, let's see, we got temperatures in the 70s. Let's see if there's anything greater than 75 degrees. There's a few temperatures. You see it was filtered. If we put a high temperature of 100, there shouldn't be anything, right? And if we do a low temperature, freezing 32, then everything is the same because there was nothing lower than 32. Okay, so that shows we've got two examples here of a select all and then a select with a where clause. So the rest are, that's really, this is the meat of using the SQL database here. The update and delete should be trivial based on these examples, but let's walk through them and make sure that we understand everything that's going on. For the update, we have an update button. Let's see, what do we have it doing? It's just an on-click, and we're going to call an update method. Let's just update everything to, in the interest of time, we'll update all values to 100. It'll be a heat wave. So back to our forecast data source, we're going to do our update method. Now, the update returns the number of rows that have been updated. So instead of a cursor, we're just going to return an int. And let's call this update temperature. And we'll have a double for the new temp. Okay, so because if you go back up to the insertion, we used our content values to insert the new data. Well, we're going to do the same thing for updating. So let's declare content values. Call it values equals new content values. Okay. And then let's put in the new value. So this is going to be, once again, for forecast helper, dot column temperature. And the value is going to be that new temp that we're passing in. Oops, I forgot to add the method call, put. Okay, putting those new values in. And then from the database, we're going to call the update method. And this is similar to the other methods we're using, but like I mentioned, it returns an integer of rows updated. So let's set that equal there. We'll return rows updated, and then we'll fill in the blanks for this update method. So as usual, you can guess the first thing we need is the table name. And then the second is the values that we're going to update, and we'll pass in the content values. And the third, we're going to pass in null. It's a where clause. And finally, it's if we had a where clause, we would have parameters, and we'll pass in null there as well. Okay, I think that's everything we need. So let's go back to main activity, to the onClick listener for the update button. And all we'll do is call mDataSource.update temperatures, and we're going to update everything to 100. And what we'll do is run the update and then click on the select button to make sure that all the temperatures have changed. Okay, so here comes our app. We'll reinsert. Now we'll update. Okay, no visual indicator here, but if we go to select, everything is 100. So everything was updated to 100 because we didn't have any filtering. So if we wanted to filter, if we only wanted to update specific rows, we could use that ID column that we added. We'd have to get it first to get the appropriate ID, but then we could update the value for just that ID. And we won't walk through an example because it should be pretty straightforward. Since you have an example now of how to add a where clause, you do the same thing down here in the update statement. Okay, so let's take a look at deleting. One more method, public void delete all. We're just going to clear everything from the database. And it's a pretty simple method from the database object. We just call delete. And let's add our table, forecast helper.table temperatures. And we could have a where clause. We'll just pass in null. And we could have parameters. I forgot this comment here. I'm just leaving these notes for reference for later on. Okay, and then we just need to call this from the onClick listener for the delete button. So let's go back here, scroll up just a little bit, and we'll replace this final to do. Oops, clicking on the wrong spot. Android Studio condenses things just to make it easier to look at a glance what's going on. And you just click on the gray part to show it like this. So from the data source, let's call delete all and run it to verify. And once the emulator reloads, unfortunately delete is grayed out, so we'll reinsert data and now delete it. And now if we click on select, we can view it, and sure enough, there's nothing in there. If we try and filter, there's nothing to show. Okay, so that's a simple overview of the basic operations you're going to do on a database. That covers a lot of scenarios you're going to come across. And that's why it's an acronym that is common across programming languages: create, retrieve, update, delete. One last thing I do want to cover, though, before we move on, because it's important, is upgrading the database. So I'm just going to do another example of how to do that, and then show a few tools, and then we'll be all set. So for the upgrade, we want to go back to that forecast helper class that we haven't touched in a while. And we have this empty onUpgrade method down here that we haven't used. What happens is, let me switch to Chrome for a moment, because I've got an article that I'll link to. No, I don't. Okay. Well, I'll link to it another time in the notes. But when your app calls that onCreate, it checks that version number that we're setting here on line 17. And as long as that version number is the same, then it's going to reuse the same database over and over again. But as soon as that version number changes, then it will call the onUpgrade version instead. And that's how you can trigger an update with a new version of your app. So if we're releasing version 2.0 of our app and we have a whole new database schema that we want, then we're going to increment this database version number, and when the user installs the update and the first time they run it, it's going to upgrade the database, and it's up to us to make sure that all their existing data migrates over if that's what we want. So that's what we're going to do here. We're going to migrate existing data, and we're going to do that with an alter statement. So let's add a new private static final string db alter. And like before, let's write it in plain SQL, and then we'll add the parameters. So we have an alter table, and I'm drawing a blank on the alter syntax. Okay, that's right. Alter table with the table name temperatures, and then we're going to add a column with a new name time, and it's going to be of type integer. The reason we're using integer for time is because if we look at the data returned by the API, it's returned in a Unix time format, which is seconds since a certain time in 1970. So this is there are utilities to convert this to human readable time, but we'll store it on the back end as an integer, and that's how SQLite, because it's a light version, that's how it stores time data. Okay, so let's just plug in the appropriate values here. So instead of temperatures, let's add the table temperatures variable. Instead of the column time, let's add a new variable called column underscore time. And just like we have column temperature, let's copy and paste and make that time. Okay. And to execute an alter statement, we use the same exact method, db.execSQL, and instead of dbCreate, we have dbalter. Now, before we just run this, though, what would happen if a new user installed version 2.0 of our app who didn't have version 1.0? If we don't make sure to also upgrade that dbCreate statement, then they're going to run the old version, and it's not going to work with the new code that we're providing. So we want to make sure we update. If we're ever providing a new upgrade statement, we want to make sure that we're providing a new create statement as well. So let's change the create statement. We're just going to append here after column temperature. We'll add a comma, space, plus, and now we have column underscore time, plus, and it's a type integer. And now our create table matches the upgrade statement from the alter statement. Okay, so that's all we need to do. Well, no, it's not, because this is the important part that I kept stressing. We must increment to trigger an upgrade. So instead of version 1, we're now dealing with version 2. So now let's try it and see. And we're going to go back into the command line in a moment and just verify the data structure change. We're not going to write any additional code to look at it. Okay, and the code should have been executed right away in the onCreate method. So if we go to the terminal, and we can do schema for temperatures, and sure enough, you see that the schema changed, and now in addition to the temperature itself, we have the time in the integer format. But if we select star from temperatures, you see that it's blank values because we didn't actually insert the time. We haven't changed our code. But you can see that the column ID has been incrementing. We still have the temperatures, and now we just have a blank value. We didn't have these vertical pipes to separate before. It's just a visual cue to let us know there's an additional column there. Okay, so that's all I wanted to cover in the app itself. So again, it's an overview of the basic CRUD operations, an upgrade, how to create and set up your database. But as you do more and more with SQL databases, you may start to get involved with using the content providers that we talked about, or you may want to use some additional tools to make your development life easier. So you may be familiar in other environments with abstracting that data away. We've got that data source object, but we can take it even further by using model objects that have additional database behavior that we can access from our activities. So I'm going to give a quick rundown of a few things, a few tips for SQL development for Android. The first one here is a really useful way to run some commands in the ADB shell that makes all SQL statements logged to logcat. So this is great for debugging. Instead of having to log your own statements, if you turn this on, then every single SQL statement from the device will be logged in logcat, and you can take a look and make sure that the SQL you're expecting is coming through the device. The next tool here I really like. It's an open source library called Android DB Inspector. And the way it works is this version is just for Android Studio, so to get it to work with Eclipse would take a little bit of work. But it's a library project that you set in your existing project, and then you change your manifest, you add a debug manifest. It's a little bit convoluted. If you want to try it out and you have any trouble, certainly stop by in the forum and let us know. But once you get it up and running, when you run your app from Android Studio, it will load up this DB Inspector app on the side with a separate launcher, and you can view the data for your app. And you see in the screenshots here, there's the database file. It's got its individual tables. If you click into tables, you can see the structure, and you can also see the content. So it's a nice way to look on the app at the data behind the scenes. And then lastly, I have two different versions of, how do you want to call these, abstraction models for taking your data into plain Java objects that you can then reuse in your app. And that just makes your code easier to understand and maintain. If you're working with a forecast object instead of writing your SQL and working with it directly, then your code in your activities and elsewhere is a lot easier to understand. The first one here is called Green DAO. DAO stands for Data Access Object. And this is a wrapper around the SQLite database. You can see here they have some claims about increased performance, small memory consumption, and easy-to-use APIs. I haven't used this one myself, but I've read reviews and performance tests that say this is a good library to try out. And the last one was just brought to my attention yesterday. I was talking with one of our mobile developers, Joe Steele, and he mentioned Cupboard, another library that does some of the same things. It abstracts out that database layer, and it uses plain old Java objects to, and here the example I think illustrates. So in your activity, you'd have this code with the Cupboard library, with the database that you provide. You put a booked object, so it puts that book into the database and makes it a little bit cleaner to insert or extract data from the database. So that just about does it. Thanks a lot for sticking through to the end here. I'm going to check and see if there's any questions at the moment. And again, if not, if we don't get to them, then we will catch up on the forum. Okay, so Jonathan asks, is there a reason why I decided to use big decimal versus the auto-boxed double class? No, I could have just used that. I feel like I may have had a reason before, but no. Yeah, so yeah, what that's referring to is where we're taking the double values, the primitive values, and adapting them for the display. We could have just used the double with a capital D as the more complete object data type that is usable within the array adapters and within the list. Okay. Looks like there may not be any other questions at the moment. Okay, great. Again, if you have any questions, follow up in the forum or find me on Twitter @BenJacobin, and thanks so much for watching. See you later.